Hi all, so in last video we have discussed about the consumers and internal working of consumers. In this video we are going to focus on the consumer groups, like what is consumer group, what is the need of introducing the consumer group. So understand it with this topic, like why do the need of this consumer group comes into the picture. So let's understand. Suppose we have one topic. This is our topic, and in this topic we have multiple partitions, and like producers are producing into this topic, and we have one consumer which is consuming from this topic from all the partitions. So this is my situation. Now now see what happens is every producer is producing their data into this topic, and only one consumer is consuming a lot volume of data. So just understand this with an example of your office work. Like suppose this is topic, understand topic, compare it with your manager, and this consumer compare it with only you. Like in your team only your manager as well as you two are present, and you two makes one team. One project comes in and your manager assigns all the tasks to you. What will happen to you? You will be overburdened, overloaded. And what happens if you fall sick someday? So just understand these two things. In case of this, only one single consumer is present. What happens, like if this consumer falls down, how this data is going to be consumed? Because since by default the data retention period in Kafka is 1 week, so we need to have some alternate option with us. Other than that, it has a huge volume of data present. These partitions have huge lot of information, huge lot of data present here. This single consumer is consuming all the data, and definitely it is overloaded. It has to consume from each partition. So in order to overcome this situation, in order to overcome this office situation, when you fall sick for a week and and the team work is pending for a week, what manager has decided? Manager has decided that he will hire some more team members so that work can be equally distributed, and if you or one person falls sick, the other people can manage. Likewise, the same thing happens here. More consumers comes into the picture. Since all these consumers are part of same application, so they are termed in one single entity called consumer group. So that is here the consumer group role comes into the picture. Whenever we create any consumer in our Kafka application, Kafka by default assign that particular consumer to a consumer group if we haven't specified any consumer group. So, and if also all the consumers are part of same application, they are referred to only to that same consumer group. They will be referring to same consumer group. So what we can conclude from this example? Why the need of consumer group comes into the picture? So as to make your application scalable, as well as so as to deal with the fault tolerance. That is why the concept of scalability comes into the picture, and that is how consumer groups comes into the picture. And the main purpose of introducing consumer group is to help in parallelism. Now what is parallelism? So understand, I have this topic, one topic, and this has 3 partitions. This is P0, this is P1, and this is P2. Initially, this is my consumer group. Name it as consumer group only, consumer group. Only one consumer is present. This is reading data from every partition. Now, this is consumer group. This one, it has added one more consumer, C1 plus C2. Now, what will happen? Understand it like this. C1 is reading from P0 and P1, and C2 is reading from P2. Parallel processing is happening now. They are parallelly consuming the data from the partitions. Now, there is one more scenario where in same consumer group, one more consumer got added. This is C1, this is C2, and this is C3. Now, C1 is reading from partition 0, C2 is reading from partition 1, and C3 is reading from partition P2. Again, consider one more example where C1, C2, C3 and C4 are present. 4 partitions are, 4 consumers are present in one single consumer group. What will happen? C1 is reading from partition 0, C2 is reading from partition 1, C3 is reading from partition P2. Now C4, the 4th consumer, will remain idle in that case because you do not have any more partitions. So what we can conclude from this thing, that your number of consumers should always be equal to the number of partitions but cannot be greater than that of number of partitions. Why? Because in that case your consumer will remain idle. That scenario will be helpful in the case like if suppose C3 goes down, then C4 comes into the picture and start consuming it from the P2 partition. So that is how consumer group helps in parallelism. So this is all about the consumer group. In next video we will discuss about some more theory part, and then we will move it to the practical part. So that's all for this video. Thanks for watching.